We start with this expression, and the instruction is to factor it as much as possible. Okay? Well, first thing we want to do is, first thing we notice probably is we got 5, 10, and 5. 5 goes into each of those, so we know that we can pull out a 5. We also have an a squared on each term, so that's common. That's a common factor. B, we have a b on each term. So each of these three terms has a 5a squared b. Now this one actually has 10a squared b, so you're going to have to multiply this by 5 or by 2 in order to get to 10, but that's okay. Okay, but the other thing you can see is there's a c that's common to all three of them. Okay, and some people got 5a squared b. That was good. Continued to factor it, came out all right. But then we noticed that there was a c in each of the terms that you ended up with. So what we do is we factor out a c as well. And by factoring this out, that means we want to find what we multiply this common factor by in order to get the original expression. So what would we have to multiply 5a squared bc by to get 5a squared bc cubed? Well, we've already got 5a squared b here that matches the 5a b squared c here. And we got a c, but we need a c cubed, so we'd better multiply that by c squared. Okay, now we're going to have to multiply the 5a squared bc by something to get the 10a squared bc squared. And what would that be? Well, to get the 10, we have to multiply 5 by 2. And to get a c squared, we're going to have to multiply this c by c. So we got c squared plus 2c. And then the third term is just 5a squared bc. So what would we multiply by 5a squared bc in order to get 5a squared bc? Well, the answer, when I pose it like that, everybody says, yeah, well, that's 1, okay? So if we multiply this, we multiply the 5a squared bc by c squared, we're going to get our 5a squared bc cubed. And, I'm going to back up because got a couple of distractions that happened just before class. And I apologize, but I need to be focused on both students who need some ADA compliance. Okay, so somebody who is, for example, visually impaired kind of needs to know what we started with. Okay, so we started with the expression 5a squared bc cubed plus 10a squared bc squared plus 5a squared bc. We notice that we have 5a squared bc as a common factor of all three terms. We then write out the 5a squared bc and give some parentheses and figure out what has to go in that parentheses. So when we multiply it by 5a squared bc, we get the original expression. Then I said, well, okay, the first expression is 5a squared bc cubed. We factored out 5a squared bc. What would we multiply by that to get 5a squared bc cubed? The answer is c squared. So we have to multiply by c squared to get the first term. We multiply our 5a squared bc by 2c, and 5 times 2 is 10, and a squared bc times c is abc squared, and that gives us our second term, 10a squared bc squared. The third term, 5a squared bc, is identical to what we factor out. So what would we multiply by the 5a squared bc in order to get the original 5a squared bc. We have to multiply it by 1. So the factored expression is 5a squared bc multiplied by c squared plus 2c plus 1. Now there's a further step, and nobody took the further step because everybody was focused on factoring out this monomial. The 5a squared bc is a single term. It's called a monomial. But the c squared plus 2c plus 1 can be factored. Okay, so let's take a minute and see if we can factor that. How can we factor c squared plus 2c plus 1? Now, if you've done the homework that's due for this time, you would have practiced with these special products, so you would have immediately recognized special products. Some did, some didn't. So, just a plug for doing the homework. But by special product, this is c plus 1 quantity squared. C squared plus 2c plus 1 is of the form a squared plus 2ab plus b squared if a is replaced by c and b is 1. Okay, so again, you need to practice and see this in many different contexts so that you'll learn to look for it and apply it. Now, as soon as I gave that hint, everybody got it. Okay, so that's good. Do practice. Okay, now we want to move on to factoring trinomials. And actually, I'm not sure that the assignment on special products was due. The one on factoring monomials, I think, isn't due until maybe tomorrow. Okay, so just be sure we get those done. Okay, trinomial. How about this one? X squared plus 5x plus 6. Now, right away, you can see that if you're trying to use one of the special products, your A would have to be X. And if your A has to, because there's no other number in front of X, right? So A just has to be X if A squared is going to match up with X squared. And then 6 would have to be B squared. And you're not going to go there because the square root of 6 isn't a number that you know. Okay? It's around 2.4, between 2.4 and 2.5. Okay? And it's not a whole number or a fraction, a rational number fraction with the integers. So special products aren't going to be held. Okay? What we do know is that if this does factor, and there's no guarantee that it does, if you do x plus 1 times x plus 6, you have x times x, which is going to give you x squared. And you have x times 6, which gives you 6x. And you have 1 times x, which gives you 7x, right? So from the 1 here and the x here, you get an x. From the x here and the 6 here, you get a 6x. That makes 7x. So it doesn't match. Okay? So this equals this doesn't match. Now, are there two other numbers you could put in here? numbers you put in here are going to end up multiplied by each other to give you 6, right? What are two numbers that multiply out to 6? Just show me with your fingers because we can't talk while the camera's on. 2 and 3. Okay, put a 2 there and a 3 there and see if you multiply it out and see if it gives you this. Once more, we have x squared plus 5x plus 6. X plus 1 times x plus 6 gives us x squared plus 7x plus 6, which doesn't match. Now, if we write set of parentheses with an x plus and a blank, another set of parentheses with an x plus and a blank, what two numbers could you put into those blanks that would give you 6? And would those two numbers then result in x squared plus 5x plus an expanded result of x squared plus 5x plus 6? Okay, now everybody got that. There aren't many choices for two numbers multiply out to give you 6. Okay? It's got to be 2 and 3. It doesn't matter whether you do 2 and 3 or 3 and 2. It doesn't matter which of the two numbers you put in which blank. But what we now have is x plus 2 multiplied by x plus 3. And then using the distributive law and so forth, it's going to give us x squared plus 2x plus x squared plus 3x. It's 2x plus 6, which is x squared plus 5x plus 6. Okay, let's try another one. Let's try x squared plus 7x plus 12. Okay, now everybody got this by one of a variety of methods. One method is trial and error. Okay, what are our options? We could do x plus 12 times x plus 1. That would give us an x squared, and a 12 times 1 would give us 12. Again, the problem is x squared plus 7x plus 12. So x plus 12 times x plus 1 would give us the x squared and the 12, but then we'd have a 12 times x and an x times 1, which would give us 13x. So that's not right. That's going to give us x squared plus 13x plus 12. So we try a different way of breaking down 12. We try x plus 6 times x plus 2. 6 times 2 is going to give us 12. X times x is going to give us x squared. But the 6 and the 2, well, the 6 in the first binomial is multiplied by the x in the second, so we get 6x. And the x in the first binomial is multiplied by the 2 in the second, so we get 2x. That makes 8x. So we're getting closer. But it doesn't quite match. We got 8x where we need to have 7x. So the next thing we're probably going to try is x plus 4 times x plus 3. And that works. We're going to, of course, get our x squared. And since we used 4 and 3 for the numbers, we're going to get our plus 12. And then the 4 in the first binomial multiplies the x in the second to give us 4x. The x in the first binomial multiplies the 3 in the second to give us 3x. And 4x and 3x gives us 7x. Okay, well, starting to have fun, so let's do a couple more. They do get a little more complicated. Let's try, everybody's doing pretty well with this, so I'm going to throw a little curveball at you. Let's try x squared plus x minus 6. Okay, now what are we going to do with x squared plus x minus 6? Well, we're going to write an x in a set of parentheses with room to put something else in it. Then we're going to write another x in parentheses with something, room for other stuff. And I guess what we're going to do is we're going to put a plus in one of them and a minus in another, because we got a minus 6 here. So the two numbers that we use have to multiply out to give us negative 6. So we're going to say it's going to be x plus one of those numbers times x minus the other one. We have to figure out which number is which. Now the two numbers have to multiply out to give us 6. So I'm just going to list, there are 4 possibilities. I'm going to list them all, and then we're going to talk about how you can avoid having to list them and reason it out, which pretty much everybody that's here today in class is doing. Good job of reasoning, but we want to build that for a bigger context. Okay, so it could be x plus 6 times x minus 1. Okay, but that would give us 6 times x and x times negative 1, which isn't going to give us just a plus x. That would give us 5x. And that would be x squared plus 5x minus 6. So it doesn't match. Then we could try x plus 3 times x minus 2, because 3 times negative 2 multiplies out to give us negative 6. And when we work this out, well, that works out. The 3 multiplies 3 in the first binomial multiplies the x in the second. The x in the first multiplies the negative 2 in the second. So we're going to get 3x negative 2x, which is just plus x. So this multiplies out. This gives us x squared plus x minus 6. Now let's go back to a couple of the earlier examples and then see how we can reason this out. You see that in every case, let's take the x squared plus 7x plus 12 case. We can solve this by figuring out what numbers multiply out to give us 12. Okay, well, that would be 12 and 1, 6 and 2, 3 and 4. Okay. The 7x has to come from adding those two factors. So we're trying to find two numbers that multiply out to 12 that add up to 7. Okay. Now we already know what the solution is, but let's just write this down. Find two numbers I'll say whose product is 12 and the sum is 7. Okay. Well, the two numbers, there are 3 possibilities. We could try 12 and 1 multiplies out to 12. I'm going to write it this way. 12 times 1 equals 12. 12 plus 1 equals 13. Okay, the 12 is fine. The 13 doesn't match the 7. And then we could try 6 times 2 equals 12. 6 plus 2 equals 8. And 8 is not 7. Okay, but we're getting close. And then we try 3 times 2, 3 times 4, sorry, equals 12. 3 plus 4 equals 7. And that's the winner. That matches the solution we figured out by trial and error. Okay, we're still doing trial and error, but we can just do it with the numbers. Okay, if we go back to the first one, x squared plus 5x plus 6. Well, 1 times 6 is 6, but 1 plus 6, which corresponds to the 6x plus x that we got when we did the distributive law. 1 plus 6 gives us 7, so we're going to end up with 7x. Then we try 2 and 3, x plus 2 times x plus 3. Well, we use 2 and 3 because they multiply out to give us 6. Their product is 6. And then 2 plus 3 gives us the 5x. Can you remember that when we did the distributive law, of course, we got a 3x plus 2x, which gave us 5x. You want to think about how all that fits together, partially so you retain it, and partially so you just have a little better mathematical insight. So let's try a good one. Try x squared plus 5x minus 36. Okay, most people got that pretty quickly and pretty easily. Going to be a little more systematic. A lot of people kind of did it in their head, and that's fine. But let's look at 36, okay? And I'm just going to reason it out here as follows. 6 times negative 1 is negative 36, right? There's one of your possibilities, but obviously that's not going to work. Okay, 36 plus negative 1 equals 35, not 5. 18 times negative 2 is negative 36. But 18 plus negative 2 equals 16. And then we have 12 times negative 3 equals negative 36. But 12 plus negative 3 equals 9. And of course, we're trying to get two numbers that add up to 5. We're getting closer. Start 35, 16, 9. Maybe the next one will do it. How about 12? About 9. 9 times negative 4 is negative 36. And 9 plus negative 4 equals 5. Aha. You got it. Okay. Just a test. x plus 9 multiplied by x minus 4 equals x squared plus 9x. Yep. There are two ways to do the distributive law, and I'm not writing out all the steps. I think it'll be easier for everybody to see. If I do x squared minus 4x, multiply the x by the x in the minus 4, and then the 9 by the x minus 4 gives us 9x minus 36, and that, of course, equals x squared plus 5x minus 36. And then we'll put a big check mark next to that. Aha means we think we found the solution. Check mark means we verified that we got the solution. Fair enough? Okay, very good. Let's say we have two x squared. Well, let's get the number over here. Plus 5. No, there's only one way to break down 5. We'll go with 32. Okay. Now I know what I want to get. Um, and I think it's going to be 16x. I don't guarantee this is going to work because I just made that up in my head, but it should work. Okay. But remember that little fender bender right before class. That kind of distracted me. It's not a big deal, but at least that's what I'm blaming it on. Maybe I'm just distracted today. Okay, so here it is. Now, what are you going to do about that? Well, systematically, you put a 2x here and an x here. Everything's plus up here, so you know we're going to be doing a plus and a plus. So we can check out, again, numbers that multiply out to 32, right? So we could start with 32 and 1, but that equals x squared, 2x squared plus 34x plus 32, so that's not it. I'll keep wanting to put 32 down there. Okay, we'd use 16 and 2. That gives us 2x squared plus what? We got 16 times x, and we got a 2x times 2. So that gives us 20x. Okay, well, we're a lot closer to getting that 16x than we were. So let's try 2x plus 8 times x plus 4. And that's going to give us 2x squared. We're going to have 8 times x and 2x times 4. That's 8x and 8x, and that is 16x plus 32. And that checks it off. Okay? What if we had two x squared? Okay, let me figure it out again. is 2x squared plus 12x minus 32. Go ahead and give that a try. Okay, again, we can systematically try factors. And I will comment that on both this problem and this one, really, we probably wouldn't even do this because we'd probably factor out the two. Okay? And then we just have trinomial with leading coefficient one inside the parentheses, and we could factor it. Okay? But I chose these numbers just because they're fairly easy to work with, and they still illustrate what has to happen. So we could try 2x well, we could do plus 32, 2x minus 1 equals, and we probably wouldn't even try that because 2x plus 32 times x minus 1, right? Again, our goal is 2x squared plus 12x minus 32. So then minus 32 could be a 32 and a minus 1. And that's obviously going to be a non-starter. You're going to have 32x minus 2x. You're going to end up with 30x. So we try 2x plus 16 times x minus 1. And you get 16x. 16 times x is 16x. And then the 2x times minus 1 is minus 2x. Now we get 14x. And then 2x plus 8 times x minus 4. And my brain is just not engaged. Okay, then 2x plus 16 times x minus 1. Well, 16 times minus 1 is not negative 32. It should have been x minus 2, in which case I would have gotten 12x. Okay, now if we do 2x plus 8 times x minus 4, what's that equal? Well, 8 times x is 8x. Negative 4 times 2x is negative 8x. I'm going to say, no, we get 0x. Kind of out of options. We try 2x plus 4 times x minus 8. That's not going to work. No. Okay, so not sure that one factored. Let's see what you got there. Like that. Well, okay, I messed up on something. It's 2x plus 8 times x minus 4. It's 2x plus 16 times x minus 2. 16 minus 2. It does give us 12x. I said, no, it gives us 12x. I'm sorry. Damage to my vehicle is minor. All I've got to do is change a tire. Damage the other guy's vehicle is a little more than that. The thing I'm concerned about is one of the passengers of his car is claiming to be hurt. So, he looked like he'd been hurt. And I'm not worried about that. I'm just hoping he's all right. I guess I am a little worried about that. Okay. So when I said nope, you get 12x, that was, yep, you get 12x, and that's it. Okay. Okay. Now if you have something like um 45x squared plus 29x minus 120. Okay. You can see where it get really complicated because 45 has factors of 3 and 9 and 5, right? 120 has a bunch of factors. Okay. Um, you get 2, you get 2, you get 2 is a factor 4 times. So you're going to have 2, 4, 8, and 16. A factor 4 times. Half is 60, half is 30, half is just 3 times. Okay. 2, so you get 2, 4, and 8 as factors. And then you get 3 and 5. So those combine to give you a bunch of possible choices. So it gets a little more complicated. All right. So your text will give you a method for sorting all that out. Is writing the factors down and using your intuition and stuff like that. You've got good intuition, but not everybody has good intuition. And not everybody can visualize everything that clearly. So there's a method where you can check everything out pretty efficiently. Okay, well, we're still got a few minutes left, but not really. We're just right now, I guess we're out of time. Okay, so that works out because this is just a preview. This is stuff that we just did with a coefficient other than 1 in front of x squared. Won't really be covered officially until next Monday, but I wanted to give you a preview of. Okay. Okay, get the homework done. That's the way you're going to remember it.